Hello everyone, welcome back to another video of ConceptBio where I'm talking about the amino acid structures and how to remember them easily. In this final video, I'm going to be talking about how to remember the hydrophilic polar uncharged amino acids. Now, in my previous video, which I'll link in the description, are the hydrophobic amino acids, which I've already discussed, and the hydrophilic polar charged amino acids. So now in this final video, we'll look at the remaining amino acids, which are hydrophilic polar uncharged amino acids. As always, this worksheet will be available for free of cost in the link in the description down below. So let's begin. The first amino acid in the hydrophilic polar uncharged group is serine. Serine is a simple amino acid which has a hydroxyl group as a functional group. So remember, like I always mention, all amino acids except glycine will have a beta carbon attached, and to this beta carbon you just have to draw an hydroxyl group, an OH. So this is a structure of serine, and it's as simple as that. Now serine and threonine are the two amino acids which have an OH group directly linked like this, and it's just how to remember this structure is threonine has a single letter code of T. You just have to draw a similar T structure with your beta carbon, and that's all. So if this is your beta carbon, draw a T and add an OH group to it. And this is a structure of threonine, and it's as simple as that. Now let's go into cysteine. Cysteine, as I mentioned before, is one of the two amino acids which have a sulfur group attached to it as a functional group. Now how to draw it is from your beta group, just draw a thiol group or a sulfur group to it. So this is a structure of cysteine, and it is very important to note that cysteine forms disulfide bridges. Between two residues. So if you have a protein structure and over here you have two cysteine residues, what happens is it forms a sulfide bridge between the two residues, and this actually helps in the folding of a protein and the stabilization of the fold. So this is good to remember. Then moving on, next would be the next amino acid is asparagine and glutamine. So both of these have, remember, they have an amide group on it. So how do you draw it? Asparagine, you just have to draw the beta carbon and directly to it add the amide group. What is an amide group? Just a C double bond O attached to it and NH2. Alright. So, and glutamine and asparagine, similar to how glutamic acid and aspartic acid was similar by the addition of a single carbon atom, it is similar over here. From asparagine, addition of a single carbon atom will give you glutamine. So from your beta carbon, draw one more carbon atom and then you draw your amide group, NH2. See, two beta carbon and an additional carbon group over here, whereas here it's only a single beta carbon. So this is the difference between the two, and it's as simple as that. Now it's all, someone will ask me suddenly, hey, didn't you look at this? This has an NH2 group in the ending. Shouldn't this be a polar charged amino acid? Well, it's a good observation, but the problem here is that it's not only an NH2, but there is also a C double bond O group here, and this whole thing in total is known as a amide group. So when you have C double bond O NH2, it's known as an amide group, whereas an amine group is just an R. If this is R group attached, this will be NH2. This is an amine group, amine. I know it's a little confusing, chemists are kind of confusing like that, but remember that because of this kind of structure form, this falls under the category of polar uncharged amino acid, because this won't be ionizable at all. This NH2 won't be ionizable. Okay, so this brings us to the end of all our polar uncharged amino acid. There are two additional amino acids which I'll just look into, that is selenocysteine and pyrolysine. Usually textbooks don't consider them as to be standard amino acids because they'll either say 20 or 22 amino acids. If you say 22, you'll be talking about selenocysteine and pyrolysine too. If you say 20, you're talking about only till glutamine. Okay, so don't get confused about that, don't need to panic. So I'll just show the structures if needed. So selenocysteine is similar to cysteine. Okay, the reason they say seleno is because instead of the thiol group added over here, a selenium group element is added. What is selenium? First you just draw the beta carbon and attach the selenium group to it. What is selenium? Selenium is an element found in the, it has an atomic number of 34, and this is what selenocysteine residue amino acid looks like. Now, and it's similar to the cysteine molecule. Cysteine amino acid, I'm really sorry. So, final one is pyrolysine. Pyrolysine is again just a modification of lysine, but a little more bit modification occurs, and this structure is actually quite difficult to remember, and it's never really asked anywhere, but it's for your information. I'll obviously draw it. So how do you draw pyrolysine? First start with the lysine part of it. So how to draw lysine, as I showed in my previous video, from the beta carbon, draw your K value. I'm sorry about that. Draw your K value. From the K, attach it to the beta carbon. So you have one carbon atom over here. This is your second carbon atom, third carbon atom, and then from here attach it to your NH, which so far it looks like lysine. True. Then from here is where the fun starts, where you have to draw this kind of structure. It is quite difficult to remember, and frankly speaking, I highly doubt anyone would ask it in an interview or a paper question, but it's always good to know it. And this is the structure of CH3. This is the structure of pyrolysine, where you have a complex ring structure over here with the methyl group attached to it. From that, add the lysine structure over here. So this is the structure of pyrolysine, and it's I know it's difficult to remember, but try to remember the remaining amino acids, because these are important. Now you can ask me what's the point of learning all this? What's the point of learning all these structures? Well, the easy reason is, if you know the polar charged amino acid, those are your ionizable group amino acids, and they are important when you want to know your structure for isoelectric point determination. So you can extract a protein from a large sample of protein structures. Suppose you know which residues will be charged at a particular pH, you'll be able to extract them out. I will talk about this little later in my isoelectric video. And another important aspect of this is to know which amino acids are similar to each other. So if you're looking in bioinformatic work and you're trying to do a modification of a protein structure and you want to change a residue, suppose you have a residue and you want to change in one of the alpha helix, you want to change it from asparagine, for a modification study, you can add glutamine to an extent, but you can't suddenly change asparagine to a hydrophobic amino acid and expect the structure to be similar. And you can an easy example for this would be in the case of sickle cell anemia, where a single amino acid change led to a change from structure of the RBC to look from this to sickle cell shape. So it's always good to remember the structure of amino acids. And as always, if you're looking from an academic perspective, this is a question done to test your basis for your biochemistry. So it will be asked in interviews in PhD, or it will be asked in GATE questions or IISc or IIT competitive exams, or even in foreign university exams. These questions can be asked. So I hope it gives a little bit of justice to why you have to spend your time to learn these structures, and try to have it in your fingertips. So this is basically it. This brings an end to the amino acid structure determination, and now we can have a little more fun in the next videos with learning how to do the isoelectric point determination, how to extract proteins, and so on. So thank you for watching. If you feel you have any doubts or need any more clarity, feel free to ask any question in the comment section below. I will get back to you immediately. And I hope you enjoyed it. Feel free to leave a like if you liked it. And thank you. See you in the next video. Bye.